Good afternoon, everybody, and thank you for joining the Association for Business Process Improvements monthly webinar meeting. Today, we will talk about creating requirements that will deliver goals and proving it. The next step in creating optimal business design. Before we get started and I turn it over to our presenters, I'd like to take care of a little bit of housekeeping from a format perspective. Today you'll hear from Keith Luce and Dan Morris about their experiences in this area. And later in the presentation we'll hear from Kevin Field from ProModel, who will walk us through a brief look on how simulation really works in the business arena. I will ask everyone to please send their questions in at any time, but we will hold them for answer till the end of the session. If we need to continue beyond the scheduled time to address any other questions, we can extend a bit longer if needed. If you have any questions after the meeting, we ask that you please feel free to send your questions to Keith Luce, Dan Morris, and or Kevin Field from ProModel, and they will follow up with you directly. If the line drops on you, please dial back in, or if you experience difficulty in the audio. And with that, I'd like to do a brief introduction of our two presenters, Keith and Dan. First, Keith Luce is the Vice President of Consulting and Business Transformation for Exceller. Keith has over 25 years of experience advising business leaders in multiple industries to include healthcare, manufacturing, as well as the financial services, and I'll let him go into any more detail if he wants to elaborate. Dan Morris also serves as our Vice President within the Exceller Consulting. Dan has over 30 years of experience in business and IT operations transformation. He's the creator of the ABPMP, the Architect, Design, Deploy, and Improve, the BPMS methodology. He's also the author of 4 books on business transformation and has over 50 papers and articles published to his credit. And with that, I will turn it over to Keith Luce to begin the presentation.
Todd, thank you very much for the warm intro, and welcome everybody today to today's webinar. As Todd mentioned, today we're going to be talking about iteration and actually taking you through a live demo of a simulation tool that we've found to be very effective in the marketplace. So today's agenda is going to focus around a variety of topics that we have listed here, but to kind of boil it down for everybody, we're going to really be talking about how to best leverage an iterative approach with regards to BPM and BPMS. So how is iteration really an effective way to drive towards optimal solutioning? Some of the challenges that we see with regards to iteration and some success criteria for successful iteration and simulation to improve designs within the BPM space. We'll also talk about some simulation tools. Specifically, we'll be profiling a tool that we've seen in the market, which is a rather interesting one offered by ProModel, and as Todd said, Kevin Field will be demoing that for us. And also we'll be talking about some lessons learned as we've been doing this work for quite a while in the marketplace. So with that, let me launch into this. Clearly, as we think about BPM and ultimately BPMS solutions, it really starts with making sure that we've got the right requirements. And when we look at requirements, we kind of step back and make sure that there are 4 different perspectives that we look at. First are the initial project requirements, which often comes from our user groups, our business partners, who identify either a pain point or perhaps an opportunity space, or it could be some part of some sort of transformation where they may be looking at how can we improve end-to-end large-scale processes or customer experiences. But it really starts with understanding first, well, where is the beginning with regards to the requirements? Clearly from there, we also need to understand on a deeper level what the business requirements are for that design, and how do we really understand the implications of what that might begin to look like. And that's where we start really thinking about how do we iterate forward from the current state eventually to an optimal 2B state. And then clearly other two elements of this are the technical requirements and technical specs. As we work with technology-enabled processes, clearly we need to be partnered with our IT partners with regards to, well, what are the capabilities that IT currently has? So as we design solutions and we embed technology-enabled solutions into that, clearly IT has to be able to support that. So we need to understand from the IT perspective, A, can they provide it today? And if not, is that capability somewhere on the IT investment roadmap such that our design can take advantage of whatever those technical requirements are? Too often we find that there can be a gap between the ideal solution when it includes technical requirements that IT is not able to deliver in the near term, which obviously creates tension and dissatisfaction with regards to our business community. So something that has to be really thought about. So again, making sure we've got clear requirements and understanding what is really the art of the possible with regards to your organizational structure. As we think further about iteration, I'm sorry. Someone's flipping it. Someone's flipping as I'm flipping the slides. My apologies, everybody. So iteration is all about moving towards an optimal solution. Before the advent of simulation tools or optimators, we would simply iterate and identify where are the bottlenecks, and as we start to solve those different bottlenecks or process gaps, we start to identify how do we move towards a better solution. With today's technology around simulators and ways of optimizing our workflows, we can more quickly move towards optimal solutions and in fact understand what does even optimum begin to look like. So as we look at the BPM design, it's really understanding how do we iterate? How do we go from one solution to the next, and along the way know that in fact we are making positive and incremental impact towards optimal solutions. We use things like Lean to make sure that our processes are designed effectively. Six Sigma provides us a great suite for the deeper analytics to understand how do we really look at our metrics and analyze them to ensure that we're moving towards optimum, and then also use that data to start to pressure test what that optimal state looks like. The whole intention here is that we're creating simple process improvement solutions or BPMS-enabled solution. The challenge is how do we iterate, and also, quite frankly, is also understanding when is enough enough. You can go to 1.9, 5 nines, you can keep on moving towards 100% perfection, and I think we all can appreciate that each incremental hour that you add in trying to optimize solution, unless it's making markable difference, really starts to become very much of an incrementalist approach. So we need to understand when to slow down and when to say we've declared victory with regards to what optimal solutions look like. So we've stepped back and we've understand that there are really kind of three key problems or issues that we need to appreciate with regards to the iteration challenge. One is making sure that the iteration, so if I have N1, which is my first iteration, and N2 is my second iteration, is that in fact a real improvement over the last one? And how do I know that in fact N2 is a better solution than the first one? Second is that design really operationally feasible? Or have I designed a solution that either from an operational or from a technology perspective, in effect is either impractical or does not cannot be enabled because IT doesn't have the capabilities from an IT perspective. And then finally, as I suggested before, how do I make sure that I understand that I am driving towards those optimal solutions? And again, this is all set in the context of making sure that I've got solid requirements, which really establish the context from which all this comes together. And so we found that one of the more difficult things around iteration is making sure that we have the data that allows us to really start to model the current reality. And as we think forward and think about some of the simulation tools that are available, we've discovered that in some organizations there's lots of data that can be used to be analyzed, and others there's less so. And that really affects the quality of the simulation that we're going to be able to really create for ourselves. And so really having effective data around volume, staffing, work rates, costs, because we're going to model then what the as-is solution is, and then we're going to use our optimization algorithms to then go from N1, 2, 3, and so forth to see if we can't move more towards that optimal solution. What we've discovered, too, is that these workflow simulation tools are great not just to drive us towards optimization, but it also creates a very nice way for our stakeholders, our business partners, to really start to see in both a graphical and a data-based view of what that solution really looks like. So I can now really model and say, here was a bottleneck in my process, a bottleneck which was described as X. And this bottleneck has been resolved by applying different process tools, process improvements, or technology interventions, and we can then actually demonstrate that. And it provides a very nice visual representation for our clients to see exactly how those changes that we're proposing will affect their business operations. Now, clearly, we have a lot of trust with regards to our partners, but this way they can actually see it, and then also in a tabular format, they can actually start to experience how does my throughput, how does my cost modeling start to shift as I demonstrate how a more optimal solution has been derived. It also helps us understand, again, where those bottlenecks are and the inefficiencies. It really helps to start to visually demonstrate what more a streamlined process looks like. And as I said, very more simply can start to demonstrate for us, well, where are those either staffing needs or potential staffing reductions or cost needs or cost reductions as we model out those various new processes. So with that, kind of establishing the foundation of iterations, how simulation can really start to be used to then get more towards those optimal solutions as defined by the requirements, I'm going to turn it over to my partner, Dan, who will pick up on the next slide. So Dan?
Thank you, Keith. Moving forward, the key issue really, from a practitioner's perspective is when we go through and, we'll do the current state model, and then we start to look at how do we really want to change that. We run into a kind of an iteration snag. And in a lot of organizations, that snag is causing significant difficulties in determining, when are you at a point that you can now actually start to build something, that you can actually start to say the solution is where we want it to be, and we now are going to actually invest in that construction. One of the problems historically has been the need to invest in the construction of something that we've iterated, and then we now start to iterate the constructed solution because it really didn't get us where we wanted to be. And one of the things when you start to look at this whole thing is, the question is, how can we remove that risk? How can we move that forward so that when we construct something, we're pretty much assured that that construction is going to deliver what we want? Now, from we'll say a workflow design perspective, Keith has been talking about the fact that when you put together your new workflow models, you're doing that based on some type of actually an iteration from the current. That iteration can be fundamentally new and different, but it's still based on the types of things that are going on today. So how do you then start to iterate and recognize that each of those iterations is an improvement over the last one? How can you find where those improvements are needed from iteration to iteration, and then how can you move that forward? And, as Keith had mentioned, the way that we found to really control that and to actually focus those changes from iteration to iteration and know when we've pretty much gotten as far as we really can would be the use of simulation tools. We've also found, though, that, simulation will deal with the workflow and efficiency and effectiveness within that workflow. But there are certain things that we now still need to do before we can get to a model, a solution that we now want to build. And part of that deals with embedding in the new design things like Six Sigma monitoring at what we'll call breakpoint. So we do a breakpoint analysis on the design. And a breakpoint is where you are able to find that a problem has occurred. It's not at this point where it's occurred, it's just where do you identify that something's gone wrong. At that point, that breakpoint, we can now redesign things upstream so that we're designing the characteristics that cause the thing to break out of existence. But we now still need to look at performance characteristics, quality characteristics, those types of things. So we start to need to embed to really see where we're at. Things like Six Sigma, different types of predictive analytics, and we want to, from a business intelligence standpoint, we want to build in those business intelligence, essentially the metrics, the monitoring, the information flows, and the reporting at this point so that we can then look at it and test it. And we also want to, because at the end of the day, we have to improve things for the customer, otherwise eventually you go out of business. We also want to build in feedback loops from a business perspective to see where that's really taking us and how that's really going. Now, to do that, we will start to, and we'll talk about a concept in just a couple of minutes called building stubs and drivers into the design. And what they do is they attach to the points where you interface, either giving data to something or getting data from something, and it'll either, in the case of a driver, pass you something canned already, or in the case of a stub, it'll just take something from you. What that does is it allows us to generate the applications through the BPMS and then stub off or driver off all the connections. So we now just have it existing within that BPMS environment. And we can now run it in a model office type of a situation where we're effectively looking at how it will work in real life. And that's where we can now look at the results of the design overall against the performance targets and against the delivery targets of the project. Now, we haven't really spent the time to build anything yet except the models, putting them in the BPMS and then flipping the switch to, essentially generate the tools or the systems. And of course, to do that, we need to put in the rules, we need to put in the data and the forms and all that type of thing. But those are things that you're going to need to do in the design anyway. What this does is it allows us to significantly reduce the risk and the cost, because at this point, we're not building anything until that now full simulation. It's a different kind of use of the word simulation at this point, but this full live run tells us we now have achieved what we want to, and where we haven't, we can then go back in, iterate again, changing things within the context of the tool, and then moving forward again to try it through the model office and then see if we've hit our targets. Once we hit our targets, we have the base all set, and we also know now where we need to put together business specs to extend the capabilities out into external systems. We know where we need to interface, we know the data that we need, we know all that type of thing because we've already tested it. And now it will go into the technical requirements, and then through the technical requirements conversion become actual design and then development specs for the technical team to put back together. Through this process, what we've done is we've looked at the staffing, the resources, the volume metrics. We've conducted different types of studies if we need to. And here, just to digress for a second, oftentimes we find that the information needed to drive any type of simulation and really any type of metric calculation in a new design simply doesn't exist or is not really very reliable in the business organization that we're working with. What we would like to suggest you think about, though, is starting someplace, asking the business people, well, okay, well, what do you think? How many of this, how many of that, how many people, what are the problems, what are the issues, what are the impediments, those types of things. And then factoring them into the design as a start. Now, as they actually use the solution over time, those numbers become more and more reliable, and the quality increases. But if you have to start at zero, well, it's not going to be as reliable right away. But it'll evolve and it'll change. As Keith said, we're now through that, we're showing and proving that we've eliminated bottlenecks and other issues. And I think it's that proof that starts to become very important, because today with most designs, it's a guess. We think this is going to be the best way of approaching this, but you really can't prove it. Through the simulation in the workflow and through the model office type of full simulation of the model, we can now show the proof. And so we now have the proof that we need to move forward in a very confident type of a manner. So, we see how the simulation at both levels can give us the best in the iteration process, and how it can then show us where we need to improve each iteration, which saves a lot of time, a lot of guesswork, and creates a much better solution, we find. If you're using a BPMS tool, the design, all the models, that type of thing will happen within the tool, or should happen within the tool. At that point, you've got the workflow, you've got the activities defined, the resources defined, the data defined, everything there. And that gives you the foundation to really move forward into the type of model office level simulation that I've been talking about a little bit. We mentioned stubs and drivers, and the types of things that they're doing and allowing us to do. But that's an old technical concept. Actually, I hate to admit it, but it's out of the 80s when I was doing some programming work. And it's a concept that just allows us to do some things without having to fully build out the solution. The technical requirements also will need to be aligned to the essentially from the upfront business requirements for the project, aligning down through to the requirements from the design for change, to the technical requirements, and then through the technical specs. There should be a clear alignment through all of that, so that you can make sure that those things that you're actually moving forward to build, all of those requirements, build from one state to the next, from the initial kickoff to the business redesign, to the technology that needs to support that design, to the actual specs for the development of those applications and interfaces. As we start to do that, we see that the people who do those specifications, those essentially the requirements start to change. And that change requires a high level of collaboration and explanation, because one of the things that's absolutely clear is that language, while great, is open to interpretation, and anything that's interpretive can easily be misunderstood. So collaboration, as you go through from the managers who put in the request, to the redesign team on the business side, to the technical guys who take the business design and convert that to technical requirements, and on through the real technical people who put together the specifications. That collaboration and that alignment becomes absolutely critical. Otherwise, you're not necessarily certain what the outcome is going to be. So, you know, right now, one of the things that I think a lot of people are wrestling with is, there's well, I'll call it a misunderstanding in the marketplace that this whole process that we're talking about, the redesign, the simulation, on through to the specification and the requirements development, is a pretty straightforward, pretty simplistic process. And the fact is, all of us practitioners know that that's absolutely not the truth. This can become very involved. It can be very intricate. And the need to tie it all together and the need to orchestrate the various groups that are going to be involved from the business side, architects, and the coordinating and orchestrating their involvement in the different aspects of the redesign on through the specification and requirements development becomes real important. Again, because as you move through this, the question becomes, what does that really mean, and what are you really trying to say, and what are you really trying to do? And each of the groups that are involved in that will have a different perspective. And especially as you start to replace your stubs and your drivers and actually build the solution out, that type of coordination, that type of collaboration becomes really, really important itself. Okay. Now, at this point, and I'm kind of anticipating, we've run through the front matter somewhat rapidly to get to this point. And we've seen that how the simulation will direct the iteration and the changes to each iteration, and how it'll help focus that, and almost most importantly, how it'll prove that the version of the iteration that you finally decide is this is the one we're going to build, you'll prove how it is the best course of action. So at this point, I'd like to turn the discussion over to Kevin from ProModel, and Kevin will walk us through a live look at how simulation and simulation engines really work, and we can then start to look at how simulation may fit into some of the things that everybody is involved in now. So Kevin, take it away. It's turned over to you.
All right, great. Thanks, Dan. Appreciate that. Let's see if we can get the video over here real quick, what we're going to watch and go through. All right. I can hear now. Process Simulator is the tool that I'm going to show you, and Process Simulator is an add-in to Microsoft Visio. So what you see here is
Microsoft Visio with Process Simulator installed as an add-in to Visio.
So
in this diagram, it's a simple diagram of a customer support request process. And what we've done is we have extended the properties of each shape so that you can add things like time to each activity or each task so that we can simulate reality in what your process actually does. Once you've defined the necessary elements for a simulation, then we can just go up to the Process Simulator tab and click Simulate. Translates the drawing, generates a simulation model, and begins to animate. A couple things that I want to point out here. As you can see, that a support ticket is flowing through the process, moving. So you immediately get some feedback to be able to validate how your process is actually occurring. Another thing that you can see immediately is that there's these little counters up here.
sorry, my mind's a blank there for a second. Support ticket, which is a phone call or an email. Thank you. I was missing the phone call there. So one of the things that you see is
this indicates
that,
cues into this particular task or activity. And as you can see, it's starting to back up. So that would indicate that there is a problem. So immediately, just through the animation, you're simulating, you can see that there are some things that need to be taken care of.
So as you're animating, you
immediately look up here, we have
some of the different things that are happening, and you get a visualization of what may be going on in the system, whether it's good or bad, right? You can get some immediate feedback. Now, up in the right-hand corner up there, we also have a simulation clock.
That's running, so we're running over simulated time. In this particular case, it's a 24-hour period. I'm going to just pause the simulation for a second so we can talk about this.
Now, I'm going to pause the simulation.
Now, one of the other things that you see is that over here, this little label is turning green. Well, that label represents an actual person that is used or required at these particular tasks to perform that task or that activity. In this case, it's the customer support person. So anytime a customer
some of the things will back up, but you'll also see that they're moving through the process
person
as well.
is being used, this label will turn green. Same thing with this
green, and we also have other ones like the little consultant is another one. So in this swim lane, right, each one of the swim lanes represents a different resource, a different individual who is required to perform the task that is within that particular swim lane. And so if they are being utilized, they turn green. Nice thing that just to give some feedback on the animation. So
this
a little bit more about the process. So
involves
as a
the
ticket
initial
comes
customer
through,
support
right,
representative
the support person
taking the phone call or the email request and determining what classification it is. Is it a software defect, or does it need to be passed on to the second level support individual for further review to identify a solution that can be sent out to the customer? If it is a software defect, then it comes down and goes through a process of reproducing the problem, determining whether there's already a workaround. If not, it needs to go through the process of actually getting this defect fixed. So let's continue with
and be fixed, right? So they send it on to the developers, and they come up with a solution, and eventually perhaps a hot fix that gets sent out to the customer. So what I'm going to do now is I'm going to actually just
maybe quickly get to the results.
Simulation. I'm going to turn off the animation.
And one way you can do that is just turn off the animation.
The results. Now, so that just finished. As you can see up in the top right, I did a 24-hour period. We quickly got to the end here. We're going to view in our statistics module, what we call output viewer, is going to show up here next. And so what's happened is that as the simulation is run, it has collected statistics, different things, different utilization. It'll show some bottlenecks, other things as the simulation is run. And at the end of the simulation, you
to our statistics module. So what has happened is you run it over a 24-hour period, and it's collected statistics to give you feedback on what's happening in the system and how it ran. So we're going to click yes to view the simulation results.
Output.
So in this particular simulation,
so one of the first things you see here is 3 different charts. Okay, and in the top left-hand chart here,
we have a
it is
few
actually the queue
chart
of our support person. So if you look at the axes there, it's showing that it's running over 24 hours, right? So you can see from hour 0 up to hour 24, you can see what the how many tickets were in the queue, and you can see that it's beginning to
statistics that we want to show. In this particular case, this is a queue of the support task or activity. And as you can see over time, that the number of tickets in the queue has begun to increase. Down here, we have the total number of tickets that were completed in the 24-hour period, which was 224. We see also another chart over time, over the 24-hour period, and this is the number of actual support individuals as they were utilized. So at the beginning, we can see that we only had about 6, and it started to increase, got up to our maximum of 10, and then basically leveled out to where we were using 100% of our 10 customer support representatives. Now, that's not necessarily good. If we're maxed out, that means that there are probably other tickets in the queue, and as you can see, over time, it just begins to increase, and we have people beginning to wait. Let's see if we can improve this process.
Now, another thing to consider is that usually what you do is you build your simulation model and you run it, but you need to validate it against your actual system. And so you take the data in your actual system and you compare it to the simulated results. And once you validate it and have the model running as you would expect, and as they match up, then you can begin to run your iterations, as Dan had been mentioning. So we're going to show you how to do that here in Process Simulator.
So back in our model, we're going to bring up our scenario
manager. We have a module called a scenario
manager. And what this is, this allows us to run a new iteration, or what we call a scenario.
Now, on our first iteration, we ran it
Initially,
with
we
about
ran
10
a simulation where we had 10 customer support individuals, 8 consultants or second-tier support, 5 testers, and 5 developers.
And what I'm going to
As
do
we
is
saw
I'm
in the
going
results,
to,
the support queue began to fill up and back up because our support representatives were being fully utilized. So we're going to run a scenario that is going
to be able to tell what kind of change we can make on that. Now, if you remember, we had the customer support person was utilized 100% of the time after about hour 8, and then we started to get some of the support tickets backed up. So what I'm going to do is create an
help us better understand
resource,
how many support individuals we could possibly use. So I'm going to create a scenario, which I'm going to call unconstrained.
What I'm going to do is call it, unconstrained scenario here,
so
or
we're going
iteration.
to increase the number of customer support individuals
just to see
20.
what kind of capacity
kind of a
do we have
pseudo
here. So I'm going to give every single
unconstrained
one of these,
scenario. We're going to do that for each one
units.
of the different resource
and
types
then
here.
once we get that in there, then
now
we're
let's
going
run
to
this scenario,
again.
and let's see what kind of results we
here
get.
we don't necessarily need to see the
we
animation
don't necessarily
going,
need
to
see the
before,
simulation at this point, although you can see that there's a lot of activity here with the resources being utilized. So I'm going to turn off the animation.
We're just going to turn off the animation
and just quickly
and
get to the results. So here we have our initial scenario.
Kevin, this is Keith Loost. If I could just interject for a moment, please. We're getting some comments from participants that they're getting a dual audio stream, one from the phone line when they're listening in, and as well as the audio dubbing on the video itself. Can you turn that audio dubbing on the video off, please?
I have the audio all the way down from my perspective. They would have to turn off their speakers, I guess. I don't have any other control over the audio.
So participants, if you would, please simply turn the audio down on your computers, and that should take care of the double audio issue. Thank you.
Yeah, sorry about that, guys. We had recorded the audio and as to run by itself, but we decided to do it live as we're going. We apologize. Okay. So let's see. So what I was starting to show here was after we ran our unconstrained scenario or iteration, it will automatically show up in the output viewer as a new scenario, if you see over here on the left. So what I'm going to do is click and check that scenario so that those statistics will now show up in the chart side by side with the previous scenario, with our baseline, or in that particular case, we call them more resources. So
and
what
compare
we're
these results side by side. If we look at the tickets in the
queue,
we can see that the original scenario was increasing in the number of tickets over time. In our unconstrained scenario, we basically kept that at 0, which is good. That's what we would assume. We were also able to increase the number of tickets that were completed over the 24-hour period from 224 to 250. And in our resource,
so we were able to increase about 6 tickets in that 24-hour period. Now,
over time, we can see that we were no longer constrained by the 10 support individuals, but we can see that it went up at various times up to over 12 CSRs that were required over this 24-hour period, and sometimes even all the way up to 13. So what this tells us is that, hey, why don't we go back and see what would happen maybe if we ran with 11 customer support representatives or 12. What will that do to our particular process? The great thing about this is you are
the queue, the actual queue, right? Because we ran it unconstrained, but we want to be realistic. We just don't have, a number of resources to be able to just throw at it. But it gives us an idea of what, if we did have more resources, what could we do? And so you can run your different scenarios, see what effect it has on cost, see what effect it has on overall throughput. What if we reduce, right, the amount of time that it actually takes to handle the initial support call and move it through the process? What is that going to do? And so simulation gives you that ability to do it. Plus, we've only really looked at the customer support person, right? We've kind of tried to solve that bottleneck for the initial support call, but what happens next with the consultant? Well, those are the kind of things you can go into and look at, and what happens with our QA and development process. So that's kind of the power of simulation and iteration, is that you don't have to interrupt the actual process, and it's kind of risk-free because you're not interrupting anybody, you're trying things out, you're experimenting, and you're learning. There you go, Dan. That's. I'll throw it back to you.
Okay, thank you.
Thanks, Kevin. This is Keith. I just want to jump in some comments. From a BPM, or I think back to my days back in the process improvement time, typically our work focused on identifying ways of improving, streamlining, reducing costs, improving the quality of key processes. What we're finding today is that the BPM professional is being pulled into other areas of looking at business operations or even the fundamental business model of some companies. So let me give a couple examples of that, which really starts to tweak one's interest around some possibilities in our space and how tools like this really can help. And so an example is there's a hospital that had 6 operating suites. And in talking to the medical staff, there was a belief that they need to expand and build out 2 more OR or operating suites. As you can imagine, any singular suite is very expensive. It's in the tunes of millions of dollars to be able to outfit an operating room with all the requirements from a medical technology perspective. And the reason why they were going to increase their capacity by 2 OR suites is because there was a belief that there was not enough throughput, enough capacity for the demand. So what a team did is they actually then simulated using the real data in terms of what booked time was being placed on the 6 ORs that were currently in place, and actually simulated out the current reality with regards to the schedule. And they determined that the current 6 were operating under capacity. And so by using some simulations, they ran some iterations. First, they demonstrated then to their sponsor saying, listen, we're running under capacity, so there may not be a need for additional expenditure from a capital investment perspective. And so the question was asked, well, how much more capacity do we have? So using the baseline data, they started to load the model, and they ran another 10% of demand through the model and determined there was still additional capacity. So they ran it again and it ramped up to 20. And finally, they determined it was upwards of 25% of additional capacity could be scheduled using the current OR suites. So here was an example where there was not a process improvement, but they were able to forego the expense of adding multi-million-dollar capital investment into a facility because they just didn't need it, whereas the anecdotal evidence suggested, in fact, they needed it. Another example, again, this is in a hospital setting. There's an ER that was constantly being backed up, and we hear this in many operating emergency rooms, that there are backups or delays with regards to people waiting. And by building a simulation, modeling out their current state, and again using data, they're able to model and say, here's our as-is state of the ER from when a patient walks in the door to when they're finally discharged or they leave the facility. And they model it out, and then they agreed this is what's happening today. And they discovered that what they thought the problem was that they didn't have enough medical staff, or they didn't have enough beds in their emergency room. Turned out that those were not the bottlenecks. The bottlenecks turned out to be in the discharge process. So those are the people who then help you exit the hospital. There weren't enough people on that back-end administration to help people out and complete their paperwork to leave the facility. As a result, you had people waiting in beds to get to the administrators. You had people waiting in the waiting room because they couldn't get to the beds because they're occupied by a patient who had already been seen, and they in turn were waiting to be exited. So another interesting example where the process bottlenecks or the pain points that were perceived by the key user, the business folks, which was around, well, we need to put more doctors and nurses into the ER environment, turned out not to be the problem. So some of the ability to simulate and iterate can start to reveal, using dynamic data, very different things than the user or the business folks thinks. So again, I encourage you as we think about process improvement and trying to work with our clients around how do we make their operations more and more effectively, there are a lot of other places that we start to add value from a BPM perspective to really help think about the fundamental operating model of how businesses think about investing, how they're going to run, additional facilities they may or may not build, and so forth. So with that, Dan, I'll turn it back out to you to help wrap up today's session.
Okay, thank you for those examples, Keith. And Kevin, thank you for the demonstration. I think both were right on target and very helpful. To kind of summarize a little bit, the key in any type of process redesign is to create solid solutions as quickly as we can with the least amount of risk and for the lowest cost that we possibly can. And in addition to that, nowadays we have the addition, really based on the continuous improvement concept, which says that, the reality of business is that it's going to change. When we include the concept of iteration and we have the foundation that, can be built in any of the BPMS-based products or projects, I should say. We then have the foundation that we need to, on an ongoing basis, look at what-if scenarios and what happens if we do this. The simulation tools that we've talked about today, the other types of concepts dealing with the model office testing and that type of thing before you have heavy investment, can go a long way towards helping you implement that continuous improvement program. So it helps not only on the front end with the initial redesign of the operation and scope of a given project, but also with controlling the evolution of that operation through continuous improvement. And, today a lot of organizations with following the BPM approach, which is iteration-based, have serious project problems with understanding, when an iteration is optimal, when to stop, when do you keep going, when do you hit the, if you draw it at an 80% improvement and, you don't necessarily up front want to take the time to get that extra 20% out. When do you reach those points? How do you do that? And, we found that running the design through the simulator helps focus those iterative changes so that we know from iteration to iteration where we still need to take some kind of design action. And we know when that type of design from a given iteration becomes optimal, as we're defining optimal within the context of the project. And we know then, based on the model office type of work that we're talking about, when the overall solution will deliver, not only will the operation be optimal, but the solution itself that's going to be built at some point in time will be the best solution in the environment. And the key is that through the model office and then through the simulation, you can prove it. You have the proof that you need to show that the design will have a very high probability of delivering what is expected. When you have your requirements based on that type of a foundation, it just makes common sense that those requirements are going to be the best requirements you can possibly get, given the ability of your team to communicate with one another, to collaborate with those other people that are involved. But the bottom line is that solution or requirements based on a design that's not really proven, you think might be good, but it's not really proven to be the best, are iffy. Requirements that are built on this type of a foundation are very different. And as you align those requirements from the initial project setup requirements or request requirements on through to the technical specifications, what you're doing is ensuring that those requirements not only are the best that you can possibly make them, but have a very high probability of delivering an optimal solution. And with that, hopefully we have gone through and answered these questions that we posed at the beginning of the discussion. And I'd like to now turn it over to Todd to take questions, and be happy to, along with Kevin, be happy to answer any questions.
Thank you, Dan. And thank you, everyone, for taking time out this afternoon to listen and join this webinar. And right now, we'd like to turn it over to questions. So on the left side of your screen, underneath the Q&A session, where we have some dialogue around the earlier audio problem that we had, if you have a question, we would like you to post it there. And in the time allotted, we will simply go in a numeric fashion and answer them 1, 2, 3, etc. And go from there. So I will pause for a little bit to see whether any questions come into the hopper, and then I will farm them out respectively to Dan, Kevin, and or Keith. And this is where we encourage everyone not to be shy.
Okay, Todd, I think we have one question from a Mr. or Mrs. DeCamp.
I am not seeing that question. So if you see it, please feel free to read it. I don't show it on my display.
Okay. The question that we have on here is, does this mean that the process design meets the business requirements and not the other way around? Process design meets the business requirements. Yes, it does. And I'm not exactly sure what not the other way around, other than the business requirements. The business requirements will, from a project standpoint, will drive the design. Once that design is done, the change requirements then will drive how changes is reflected in the business operation, and they'll together then be the foundation for the development of the technical requirements that support that new design. So the requirements up front, as given in the essentially the project request, drive over the initial design. Then that design, in our case, when we're saying when you go through the simulation and you come up with the optimal design through an iterative process, that design itself will then generate change requirements. But the goals and the initial requirements for the project have to come through the project request. Okay,
Thank you, Dan.
Another question. Sorry. Just going to say, it looks like there's another question here, specifically, I think, for the simulation. It says, can these simulations be run across multiple models in Visio? The answer is yes, and I assume that perhaps that's a reference to a current state and future state where you might have a completely different workflow. And the answer is yes. You can run different models and compare those results in exactly the same way, side by side on the same chart within our output viewer as well. So yes, that is a capability you can have.
And just to kind of expand on that a little bit, Todd, one of the things that you want to do through there is to look at how your different iterations are changing, and you have a little bit of comparative analysis between the iterations, because even though you're focusing change based on simulation modeling, it's still possible to, in a given type of change, to damage something that was okay before. So that ability that Todd had just mentioned, that gives you the ability to compare model to model and result to result, is really important in looking at how those changes are evolving and how those designs are evolving. Back to you, Todd.
All right. Well, I'm glad I'm the only one experiencing any audio-visual issues at this point. If anyone sees any other questions coming up on the hopper, please let me know. We will.
Okay, well, we have a few here. We have one from Eric Thompson. Can these simulations be run, oh, we just addressed that one, okay.
Yeah, I think I got that one answered.
Can you go ahead and read that question?
That question was, we had just addressed it from Mr. DeCamp. And we now have a question from Jonathan McKee. Any thoughts on the pros and cons between visual paradigm logization? That's a word I can't pronounce, I'm sorry. With simulation and pro model. Understanding that logization, again, I apologize for killing that word, is part of an enterprise development suite. This is probably a question for Kevin.
Okay. I think Carl's going to answer that one.
Okay.
Carl, are you on mute? Or Carl? Okay. Yeah, I am not familiar with, Carl, did you jump on?
No, I should be here. Can you folks hear me?
Yeah, we can hear
you.
Now
we can, yes.
Okay, somebody had me muted on the other end. To the question, George, your question, I think it was your question in terms of the enterprise BPM, must be a BPMS suite. I'm not familiar with that, but in the experience we've had over the last 20 years, the BPM suites do a real good job at automated workflow and everything that they do, and they do address simulation, but not as a core competency. So we find ourselves working very synergistically with the BPM tools to where either those tools can export necessary information to support a rapid process modeling simulation type event, or where you want to do the modeling up front. Sort of the theme of this presentation was before we go automate or go put in place a process, let's make sure it's the right one, and then secondly, let's test that process for robustness, something I can do in a simulation model and maybe not so easy in a real environment. That means, throw crazy demand at it or throw different things at it that will highlight the sensitivity of that system to perform, but do that in a low-risk environment. So to answer your question shortly, I'm not an expert in that system, the enterprise system that you identified, but again, we've had a lot of experiences working synergistically between enterprise-like BPM systems and what we do, which is really centered around the simulation component.
Okay. Thank you, Carl. Carl works with Kevin at ProModel, so we hadn't introduced Carl before, but hopefully that will suffice. Now, we have a question from George Masever, and again, I apologize for killing the name. Are there any time savings resulting from this model-to-model or model-to-implement approach compared with the traditional approach? The answer to that is yes, very much so. Because what you're doing is, first of all, focusing the iterative approach. In BPM, one of the key tenets of BPM is the ability to iterate, and through that ability to iterate, to evolve a solution, starting with essentially a prototype and then moving it forward. The iteration, though, when you start to iterate designs, you can get caught in this iteration loop where you just keep doing it forever. The other problem with that is, and you do that because you don't really know when enough is enough and what you've really done. and that's where the simulation comes in. The other part is as you move from iteration to iteration, how do you really know where you need to now take it to get additional improvement, really, and what that additional improvement is really going to then give you? And that's why, addressing those problems is why we started to use simulation and simulation modeling, so that we could shorten that process, and so we could prove the results of a given design. And when you go through that, you're now actually shortening the number of iterations that you need to go through, because you can focus on those things that drive additional improvement. The other thing, when you get to the full solution, you get into the model office, what you there find is that you can either essentially evolve it through iteration on the front end or on the back end after you've built everything. And if you do it on the back end after you've built anything, which is more the traditional way, frankly, because you can't anticipate up front typically unless you do what we're suggesting, you then build what you think is good instead of what you prove is good. And then you start to iterate the entire thing. When you do that, you're now not only iterating the pieces within the design itself, which are the BPMS type pieces, but you're now rolling that iteration across all the interfaces, across all the data connections, across everything, which increases the time and risk and cost of each of those iterations after you've built the final solution. So the short answer is yes, it really does save you a lot of time, it reduces a lot of risk, and reduces cost. Okay, Todd, can you see a question by Detelf?
Yeah, it looks like there's, one from Detlef Grossa, I think. Oh, it just jumped out of the queue, so yeah, I'm not sure what that one. But
so Dan, it looks like did we already go over the one from Jonathan McKee?
Yeah,
or
yeah, we did. That was
okay.
one that he said, okay, thanks there. What Detlef was asking about, it looked like BPMN and IDEF 0, which are methodologies for business process management, right? And although we don't, from our tool specifically, we don't necessarily automate the simulation models coming from those particular paradigms there, or disciplines, but we've definitely modeled those types of processes over the time. So we don't automate it, but we can model those particular types. He also mentioned something about black pools, and I wasn't sure about what the answer to that was. So
I apologize, but the questions, there were a couple of them, they just disappeared off my board. Could those people that we haven't answered questions for yet, please resubmit those questions? I do apologize for that. I did see a couple questions, and like I say, they disappeared off my list. So I'm assuming they disappeared off Todd's and everyone's list. Any other?
Dan, we'll give them a minute. We'll give them a minute. I still don't see the list, but that's fine. So if you see it, we'll give them a minute. We have a little bit of time. And while we're waiting on those questions, if they do come in, everyone please take note that of the emails you see on your screen, but also this presentation is available after this webinar. So if you would like it, please request it.
And we have a few columns and a couple of papers that you might be interested dealing with on the simulation topic and the whole concept of focusing iteration and then coming to the point where we have greatly improved requirements, requirements that, because of the approach that's taken, really are well along the way of assuring the creation of a solution that is optimal. Okay, I don't see other questions coming in.
And Dan, what is the best way for them to get access to those potential articles? Would you like them to just contact you directly? Is there a way, should they follow you on LinkedIn, et cetera, blog?
We're certainly on, Keith and I are on LinkedIn. We can be reached through the email addresses on the last screen that's up now. Any questions or any comments or anything that, if you'd like to schedule further, more in detailed demonstrations from ProModel, please contact Carl Napolitano. His number's there on the screen. And if any people who are participants, as you think about the things that we've talked about, if other questions come to mind, please send them to us, and we'll be more than happy to address those questions. If you would like to talk to either Keith, myself, or Carl about anything that we have talked about today, please let us know. We'll give you a call. And our overall goal, and the reason that we have these seminars, is to provide a foundation of things that are somewhat new, maybe somewhat different, to the ABPMP members. And the objective is to make you think and to see if that thought process will help you evolve and help you evolve in your thinking and the way that you approach both improvement and transformation projects within your companies. So if, at any time there are topics that you would like to talk about, consider further, just let us know. We'll be happy to get in touch with you.
All right. Well, with that, we are 5 minutes over. Again, we thank everybody for their time this afternoon, and this concludes our webinar.